Hello students. Today in this class, I am going to discuss the multi-relation queries as part of the enumeration of alternative plans. Because it is a continuation of the last lecture where we discussed of the enumeration of the plans for one relational queries where really only one relation is there. That means there was no joining. Okay, and in those, when you enumerate all the different alternative plans, you choose the plan which gives you the optimum cost, or you can say minimum cost, okay, among all the plans. So same logic applies here, but the difference is here is that we are using multi-relational queries instead of single relational query. Okay, multi-relational query means where in the from clause of the query you have more than one relation name specified. Okay, and one important part is that these queries can be quite expensive. Okay, so choosing a base plan for execution of these queries where you have more than one relation is actually is what is required. Okay, so is very important, you can say. Okay, so here for choosing such optimum plan, if you remember in the unit 3 when we discussed something called the left deep plan. Okay, where we created a query tree, right? From the relational algebra expression, we created a query tree where we have also discussed about, you know, the on the fly approach of execution of those queries, where the results go down from pipelining approach, I mean to say, from the down to above, and all the inputs comes from the previous node, the down node, child node, as input to the parent node. Okay, so enumeration of left deep plan is what actually is what we are going to emphasize on while selection of such queries. Okay, so what the query optimizer does, they enumerate all the left deep plan with selection and projections considered, but not as early. First it goes for the left deep plan, and then you can say after joining they go for selection and projections. So consider the query blocks like this. Select the list of attributes with a select clause. You have list of attribute list, which are basically what is projected as part of the output. Okay, from means the relations which are to be considered for retrieving the tuples. But here is, you can see, unlike the previous example, the single relation query, we have written here relation list. That means you have multiple relations. Okay, that means you are going to join. So where you have a conjunctive nominal form term, where term 1 conjunction, term 2 conjunction, term 3, that way up to term n. Okay, so it's a conjunctive nominal form. Okay, so enumeration of this plan can be understood as a multiple pass algorithm. Okay, pass 1, pass 2, that way we will actually discuss a multi-pass algorithm as enumeration of the plan. Okay, so pass 1, so let's discuss about this algorithm in detail. The pass 1, in this pass, the query optimizer enumerates all the single relation plans, okay, over some relation in the from clause. While enumerating a relation at a time, the following steps are performed. That is, what we do is that only those single relation plan, means we are just ignoring the joining part of the other relation, only those attributes which appears in the select and the where clause which does not belong to those join parts, okay, those are executed. Okay, that means while considering the plans, say involving the relation A, only those selection terms in the where clause are identified that mention only the attributes of A. Okay, so only those terms in the where clause are considered. See, in this example as we were considering, suppose term 1, okay, term 2. So in this, only those single relation term here are considered. That is, suppose for a relation A, if the term 1 contains only one attribute of relation A and no other attribute of other relation, that particular term will be considered, okay. So it is only identified, mention only the attributes of A. These are the selection that can be performed when first accessing A before any join that involves A, okay. Because when we say the only relation, only the attribute of a particular relation A in the where clause for a particular term, means this can be performed before any join operation, okay. So identify those attributes of A not mentioned in the select clause or in the terms of where clause. These attributes can be projected out when first accessing A before any join that involves. So only those, identify the attributes of those, the relation A where that attribute is not either used in select clause or in the where clause, okay, and those, so that particular attribute can be you can say projected out. That means we are not considering for this particular query, okay. There may be, suppose 10 attributes mentioned in a particular query, okay. Say suppose 5 attributes mentioned in a query. Now only some 2 attributes are used in the select and where clause of that particular relation, okay. So those other 3 attributes which do not have any role to play in that particular query, because they are not neither part of the select or nor part of the where. See, when I am saying the part of the where, I am considering now, unlike the point number 1, I am considering now the attribute which is also part of the joining operation, say which, or you can say which has a comparison with some other attributes of some other relation. So if those, even those attributes has to be kept, because those are playing a part in that particular query. But only those attributes which are neither mentioned in select nor in the where should be projected out, okay. Choose the best access method for A to carry out this selection and projection. So after this, you choose the best access method, okay. So access method means that is the alternatives through which you can retrieve the tuples, okay. So choose that best access method, whatever. If index is available, we may prefer an index to be used, because normally that is preferred, okay. If multiple indexes are available, then we will select the best index which gives the least cost, that is minimum number of page retrieval, okay. So those has to be, that particular access method has to be chosen, okay. So this is how the pass 1 is carried out for all the relations which are participating in that particular query. Suppose if there are 2 relations A, B, so first you need to carry out the pass 1 for the query A, and then you need to do the same process for the query B, for the relation B, okay. So if you have A and B 2 relations participating in the query, so first you need to carry out the pass 1 for A, and then you need to carry out the pass 1 for B, relation B. So pass 2, after the pass 1 is completed, because in pass 1 we are ignoring the attributes which are but then there are some other relations which are which it is in the term in which it is participating in a where clause. There are some other relation name also. Those type of terms we are ignoring, right? Those attributes we are ignoring. Only those attributes which has a single-handed role in the terms in the where clause, as well as that may appear in the select clause, okay. Even if there is some other attribute of the same relation appears in the select clause, that also we will have to consider, okay. So in the where clause only the role of the attribute with some other attributes of other relations comes into play, okay, right. So here those attributes which are single attributes are only considered in the pass A. In the pass B, generate all 2 relation plan by considering each single relation plan retained after pass 1 as the outer relation, okay, and every other relation as the inner relation, okay. So what, suppose there are 2 relations A and B, what you have to do in the pass 2, that after doing pass 1, you see there are it will be, there are some attributes will be projected out. So the relation becomes a smaller relation with some few attribute list, right? So even many tuples will be eliminated because of the selectivity conditions in the where clause of the terms. So even the tuple list also will shrink, right? So now it will be a smaller relation. Now here in the pass 2, those outputs of those pass 1, the relation A will be taken as the outer loop, that is the you can say by considering each single relation retained in the pass 1 as the outer relation, okay, and successively every other relation as is taken as the inner relation to perform the pass 2. Okay, so if we have two relations, once we will have to take the relation A as the outer relation and B as the inner relation, and then again we have to reverse the process. That is, B we will have to take as the outer relation and A will have to be taken as the inner relation for the same join condition. Okay, that is how it is written here. That is, suppose A is the outer relation, okay, and B is the inner relation. Okay. Now for a particular two relation plan, the list of selection in the where clause are examined and then identified. Okay. So selection that involves only attributes of B can be applied before the join. So B is the inner relation. Okay. So only those attributes that involves in the those attributes which involves only the attributes of B can be applied, and before the join that is actually done in the pass A itself. Okay. Selection that that defines the join, that is our condition involving the attributes of both A and B and no other relation, are performed on it. Okay. Why this particular line is written here in bracket is that we are considering in this example only as A and B, but for multi-relation queries there may be n number of relations specified in the query. Okay. So we will have to take two relations at a time and do this particular operation. Okay. Suppose if there are A, B, C, D, we will have to take A and B first. Okay. Then we will have to go for B and A. Then we have to go for A and C. Then we have to go for C and A. That way every combination of those relations has to be taken. So selection that involves the attributes of other relations can be applied only after the join. So if there are some more relations C and D, as I was telling you, so only after A and B done, the selection of those other relations can be applied on it. Okay. So the attributes B that do not appear in the select clause or in any selection condition in the second or the third groups are identified and can therefore be projected out before the join. That is what is done actually in pass 1. For each single relation plan for A retained after pass 1, for each join method that are considered the best access method to use for B must be determined. So for each single relation plan for pass A retained, okay, and for each join method that are considered from the pass 1 for that particular relation A, because inner relation is executed again and again for every tuple of the outer relation, right? So the access method, best access method for the B, for use of B for that particular joining condition on between A and B has to be determined, and that has to be applied. Okay. So as I was telling you, in case of even index join, was that if you have an index available, a good index available for a particular relation, suppose, then that should be the inner relation should be that particular relation which has a proper index defined on it, right? So that is what has to be done in the pass 2. That is, all the two relations joining conditions are being considered. The particular access method for all the two relation joining methods are being considered in the pass 2. Okay, and the plan tries to identify it. So in the pass 3, all three relation plans are generated. Okay, the procedure is same as pass 2, except that now the plan retains after the pass 2. After pass 2 are considered as the outer relation instead of plan 1 retained after pass 1. Okay. So what is done is that for After pass 2, whatever output has written, that is taken as the outer relation, okay? And then another relation which has, for the, if suppose there are three relations mentioned in the query, A, B and C. So A and B you have found out the proper plan in the pass 2, okay? So you now take whatever output you come from the pass 2, that you take as the outer relation, okay? And the C relation now has to be taken as the inner relation to execute the pass 3. That is, again there will be, because it's a multi-relation query, there are three relations. So again, the for minimizing the set of attributes and the tuples, okay, and proper selection with the proper selectivity, the this particular, the same process actually, it is nothing different from the pass 2 that has to be carried out. That is, by considering the output of pass 2 as the outer relation, and the third relation which has also a joining condition on it has to be taken as the inner relation. Okay. So similarly, this process is repeated for as many number of relations mentioned in the query. Suppose if there are 5 relations mentioned in the query, so this is pass 3, pass 4 and pass 5 will be there, because we will have to go on executing the same process. It is a same method is applied actually. It is actually repeated in the same way to contain the relations in the query. That is, all those other relations in the query which have the joining conditions there has to be included in that. Okay. So additional passes are dependent on how many relations you are using in the query. Okay. If query has 2 relations, only pass 2 is enough. If there are 3 relations, pass 3 has to be done. Okay. If there are 4 relations, pass 4 will also has to be executed after pass 3. So output of pass 2 will be outer relation, and the next relation will be the inner relation. Okay. So that way it will go on increasing depending on number of relations that you have. Now, if the multiple relation query contains a group by clause and aggregate functions such as min, max, sum, select, sum in the select clause, these are dealt with at the very end. Okay. So if the multiple relation queries has a group by clause, okay, and there are some aggregate operations like, you know, min, max, sum, okay, in the select clause. So these are always dealt with at the very end. Okay. The cheapest overall plan for the query as well as the cheapest plan for producing the answer is some interesting order can be obtained in this way. So basically, the objective is to find out the cheapest overall plan. Okay. So basically it is, you find the cheapest this overall plan by producing some interesting order of execution of this particular all these operations. Okay. So in this way you can go on performing all the passes. This is actually a algorithm for the multi-relational queries to find the best possible plan for execution of the query. Okay. So let us take an example here. Example of multiple relation query optimization. Okay. Consider the query tree. Let us take an example and consider this query tree. We have discussed this kind of query tree in the, if you remember, in the pipelining approach, right? So here we are using 2 relational queries where the projection is done on S name. You are trying to identify the seller's name from the 2 relations, reserves and seller, given that the both ID is 100, okay, and seller rating is greater than 5, and the seller SID is a reserve SID, that is a seller ID, and the seller ID are same. That means for those seller IDs which has a rating greater than 5 and a both ID equal to 100, you want to display the seller names. Okay, for those who have a reservation done. Okay, so you will have to go for the reserve relation to identify whether the sellers with both ID 100 and the seller rating greater than 5 have some reservations or not. Okay, so if it is done, those reservations are done, then the name of those sellers who have those such kind of reservations has to be displayed or projected. Okay, that is what the query has to do here. Okay. So in the before, see here, when you have these two relations, the input of those relations are first joined, as it is the normal query tree where, you know, where as we have discussed in the pipelining approach, those joining has to be done, and on the join some selections, that is the where clause term has to be carried out, so that some of the element tuples will be eliminated. Only those which conditions matches here, or where this selectivity matches, those tuples will be retained, and finally the projection will be done by using the projection of that particular attribute, and your other attributes are projected out. Okay. So now what we'll do for this particular algorithm, we'll basically take the same query by taking into account how selection and projections are considered early. Selections and projections are considered before the joining. Okay. Actually projection we are not considering, we are considering only selection before the joining. So the same query tree has been little bit modified to have the selection done before the joining. Okay. So here you can see reserve selection on BID, that both ID 100 is done on the reserve. Okay. And then rating greater than 5 of the selection is done on the sailor, and then this is joined and then projected. Okay. So selection has been now done before the joining. Okay. So suppose that the following indexes are there in the relation sailor and the reserves. Okay. And we are considering those indexes to be unclustered. Okay. That is using the alternative 2 for data entries. A B plus tree index on the rating field of sailor. So we are considering a B plus tree index on the rating field of sailor. A hash index on the SID field of sailor. So a hash index on the SID field of sailor. This on SID, suppose this is the sailor SID. Okay. And a B plus tree index on the BID field of reserves. So on the BID field of reserves, we are considering a B plus tree index. Okay. So there are basically two B plus tree index, one on rating, another on BID, and one hash index on SID for the sailor. Okay. So optimizer then proceeds like the way we will describe here. That is, in the pass 1, okay, in total 3 access methods can be considered for sailors. See, sailor has 2 index, one hash index which is on the SID, another B plus tree index which is on the rating, right? So rating, there is a B plus tree index, there is a hash index, and obviously by default the file scanning is always available. Scanning of the file, that is sequential scanning of the file, if you do not have index, then you can always do that, right? But when we index, normally we do not go for scanning of the files. So we have 3 methods, 3 access methods, okay? That is the tree, hash, and the sequential scan. Taking into account the selection, this as rating greater than 5, okay? So plan for access of the sailor is via B plus tree index on rating. So we'll first go for, because see, when we have this this tree here, the rating on the in joining only, you are basically using attributes of both the methods. Here the attribute, this is a single attribute, right? This is also a single attribute. This attribute belongs to reserve, this attribute belongs to sailor. So first you will be reducing the number of tuple by using this particular attribute rating. Okay. So what has been done is that is a plan for access of sailor is via B plus tree index on rating, because we are not going to go for the sequential scan of the files. So we'll be using the B plus tree index. Okay. As its cost of retrieving the tuples in the lowest compared to the other 2 access method, because so we are going to get basically for the for using the B plus tree. Now similarly there are two access methods considered for the reserves for the BID. One is hash, another is sequential access. So obviously we will be going for the hash index on the BID to retrieve those tuples in the where it matches BID equal to 100. So in the first two, the plan for joining reserves as the outer with the Sailor is considered. So we'll suppose initially we are considering the reserves as the outer relation and Sailor as the inner relation. Okay. So Sailor has an index. We know that it has an index SID, right? And that has index. So we do so. So the Sailor tuple that satisfy S rating greater than 5 and SID equal to value. So this has an hash index where the value has value is some value for the outer tuple are only needed. So we'll basically use the SID value with the hash index to match with the SID of the reserves, okay, to basically do the joining, okay. So all the available join methods are considered. The plan using, so we consider all the block nested loop join, okay, then index nested loop join, and then the short merge join. All the different, joining algorithms are considered, and the best algorithm that gives the joining on this SID equal to SID will be considered, because here we are using attribute index on both rating as well as SID. So we may have a very reduced set. So we may not go for index join. It is not. We may go for the short merge join as the best plan. Okay. So if the short merge join gives you the least cost, it depends on how many pages a particular joining algorithm is going to retrieve. Okay. Whichever gives the best method, that will be considered. And obviously, since it is unclustered, so we will be preferring for the short merge instead of, because sorting of RIDs can be done. Okay, using the short merge may be better than the index one, because if clustered index, obviously index will be giving the better cost. But it since unclustered index, so that index method may not give you the best result. Instead of, we may go for the short merge join algorithm. Okay. So similarly, taking plan Sailor retained after pass 1. Okay. So we may take the Sailor as the outer relation and the reserves, change the order. Okay. Sailor as the outer relation, the pass 2, and the reserve has the outer relation, inner relation, the pass 2. So in doing so, the reserve tuple that satisfies the R BID equal to 100 and R SID equal to the value, because on reserve SID we do not have any index. Okay, we have a hash index on B plus 3 index on the BID, right? So we will be considering this only that tuple that satisfies these conditions. So where the value is some value from the outer tuple are only needed. Okay, so for each value of the outer tuple of the Sailor, the reserve tuple are identified by using these conditions. Okay, so we'll subsequently we'll select the best access method that will be provided, and the best joining algorithm which will provide the best method, or you can say least cost for joining will be considered. Okay, so now we have the two alternative plan for the pass 2, right? So whichever is better, that will be considered, whether the reserve as outer relation is better or whether Sailor as the outer relation is better. Okay, that will be considered. Finally, the cheapest overall plan, the plan which gives you the overall minimum number of page retrievals or IO done for retrieval of the tuples, will be considered for as the base plan for executing this query. Okay, so that is how the enumeration of alternative relation or alternative plan is done for the multi-relational queries. Okay, in the last class we discussed about the single relation queries. In this class we discuss about the multi-relation queries. Thank you. So this is all that we have discussed in this class, and thank you for your attention in the class. Okay, for any doubt, please do ask me. Don't hesitate. Okay, I am always available to help you in any doubt that you have. You can meet me personally. You can send any information through WhatsApp or anything. Okay, I am available. Okay, please do come up with your doubts. Thank you.